Hi, I'm Alexanian,
And I'm Andrew Mueller.
and we did a Warren Truss Rider Paper Bridge. Like it was said before, the Warren Truss was patented in 1848. Members are only connected by angles, and it's an equilateral triangle.
It's used in both small airframe construction and model airplanes. If you ever get a chance to build a model airplane like that, it's very entertaining.
This is our MD Solids drawing of our Warren Truss. And as you can see, once again, we have the most tension at the bottom. So we thought we need to make the bottom length of our bridge the sturdiest. And actually, we decided we should make the entire outside frame the sturdiest for our bridge.
Can you go back real quick? We messed around with MD Solids for a little bit, trying to figure out what we think would work best. So this is our final result, but originally we started out with pretty much an arch design, but after MD Solids not exactly letting us test that because of various math issues, we just brought it simply back to this design. One, because it's sturdy and simple, and it was, all the forces are relatively evenly dispersed. We chose our corners to be the most likely to fail for one main reason, and that is we both have tension and compression forces acting upon that joint, and they're high enough that we thought something would potentially go wrong there.
And another reason why we chose the Warren Truss was because there's less joints and less members, and as we've seen from previous bridges, it's the joints that fail. So the less members and joints you have, the stronger and sturdier bridge you have. Because the paper, it all depends on how you roll it. The tighter you roll it, you can have it stronger, you can add more paper. It's not the paper that is making the bridge, it's the joints that are causing the bridge to fail.
So in this picture here, you can actually see this is our bottom member right here. So as you can tell, it's 3 members bundled together with staggering breakpoints in them.
Each of those rods has 2 sheets of paper rolled up within it. And over here you can see our outside frame. We did the triple member along the edges, and we interweaved them for our joints, so we had the strongest possible joints.
And here's what our truss look like. You can see our crisscrossing overlaying joints on all the edges. And you can't see it, but both here and here on these 2 members, there's actually a toothpick in there pinning them into the bottom rod. And
So,
here's our graphs.
as you can see, we had our first failure right about there, right when we reached about
That was 100. That was like
230.
yeah, 230-ish.
That was a significant fail, brought us back down. But
That failure, if you look at our bridge, is actually on one of the bottom members supporting the 2 trusses together.
And this is our displacement. As you can see, it was a constant displacement, so we didn't have any serious deflection.
And before we go on, we reached a peak of 258 pounds right up there, and that's where one of our members slid out of its joint due to the fact we didn't pin it.
It was up here, this joint, and most...
No, right, next another picture.
Oh, you do?
Yeah, there you go. It's right there.
And we should have pinned that joint because it was in tension and it just popped right out of its place because the glue wasn't able to hold at that force. So
There's a closer up picture. You can't really see it, but it's because it just pulled out and then popped right back in. So,
right when
if we were to do it again, we want to pin all of our joints, mainly those on the corners, just because that's where everything has both a tension and a compression force on it. More glue on the inside of joints would again help with the issue of the joint sliding out.
And it's more of like not the inside of the joints, it's like more glue on the members inside the frame of the truss.
And more constant rolls. We started out using a glow stick, but we don't know where that glow stick went. So we started using a Vex axle.
Yeah, I was using the Vex axles, those metal ones to roll it up. So some of them were tighter, some of them were looser, so it was very inconsistent. But
Turned out.